Good morning, my YouTube viewers. In this particular video, we're going to cover an experimental split plot design. And then so the 6 things that we do to perform an experimental design are: 1, we define the research objective. 2, we define the research methodology. 3, we conduct a literature review. 4, we develop research design. 5, we collect and analyze data. And 6, we present empirical findings. And so what I've done is I've got a question, a sample question, in order to perform the split plot design. So we have 12 rows of data that have 2 blocks, blocks 1 and 2. And we have different irrigation methods, being drip or spray. And we have different fertilizers, being A, B, C. And we have different yields. So what I've done is I've done this by hand, or done this with Excel. So in a few videos, what we've done is we've used the ANOVA with the data analysis. But in this one, we're going to do it just with Excel coding. So we're going to have the average drip, which average ifs D2 to D13, comma B2 to B13 drip, and that's 515. We're going to have the average spray, which is average ifs D2 to D13, comma B2 to B13 spray, and that's 4.75. We're going to have the average fertilizer A, which is D2 to D13, comma C2 to C13 A, and that's 505. We're going to have the average fertilizer B, which is average ifs D2 to D13, C2 to C13 B, and that's 4.9. We're going to have the average fertilizer C, which is average ifs D2 to D13, comma C2 to C13 C, and that's 4.9. We're going to have the average drip and A. So that's average ifs D2 to D13, comma B2 to B13, comma C2 to C13 A, and that's 525. We're going to have the average drip and B, which is average ifs D2 to D13, comma B2 to B13, comma drip, comma C2 to C13 B, and that's 5.05. We're going to have the average drip plus C is average ifs D2 to D13, comma B2 to B13, comma drip, comma C2 to C13, comma C, and that's 5.15. We're going to have the average spray plus A, which is average ifs, brackets D2 to D13, comma B2 to B13, comma spray, comma C2 to C13, comma A, and that's 4.85. We've got the average spray and B. We've got average ifs D2 to D13, comma B2 to B13, comma spray, comma C2 to C13, comma B, and that's 4.75. We're going to say the average spray plus C is average ifs D2 to D13, comma B2 to B13, comma spray, comma C2 to C13, comma C. We've got the grand mean of average D2 to D13, that's 4.95. You've got your sum of squares total, which is sum product, D2 to D13, minus G12, and that's squared. That's 0.59. You've got sum of squares irrigation. That's 3 times G1 minus G2 squared plus 3 times G2 minus G12 squared, and that's 0.24. You've got your sum of squares fertilizer, 2 times G3 minus G12 squared plus 2 times G4 minus G12 squared plus 2 times G5 minus G12 squared, and that's 0.03. You've got your sum of squares interaction, so that's sum of E2 to E13, that's 0.05. You've got your sum of squares error, which is G13 minus G14 minus G15 minus G16, and that's 0.27. You got your degree of freedom irrigation, so you're going to count a unique B2 to B13 minus 1, and that's 2, so that's 1. You've got your degree of freedom fertilizer, so that's count A unique C2 to C13 minus 1, and that's 2. You've got your degree of freedom interaction, so that's G18 times G19, and that's 2. You've got your degree of freedom error, and so you've got count A unique A2 to A13 minus 1 times count A unique B2 to B13 times count A unique C2 to C13, so that's 6. You got your degree of freedom total is sum of G18 to G21, and that's 11. You've got your mean square irrigation is G14 divided by G18. You've got your mean square fertilizer is G15 divided by G19. You've got your mean square interaction, which is G16 divided by G20. You've got your mean square error, which is G17 divided by G21. You've got your F stat fertilizer, which is G23 divided by G26. You've got your F stat, no, sorry, that was F stat irrigation. You've got your F stat fertilizer, which is G24 divided by G26. You've got your F stat interaction, which is G25 divided by G26. You've got your p-value irrigation, which is f.dis.rt brackets G27, G18, G21, and that's 0.06. You've got your p-stat p-value fertilizer, which is f.dis.rt brackets G28, G19, G21, and that's 0.79. You've got your p-value interaction, which is f.dis.rt bracket 6 G29, G20, G21, and that's 0.60. You've got your alpha of 0.5. So we're going to interpret it for the irrigation. For the irrigation, it's 0.06, so it's greater than 0.05. So you're going to fail to reject the null hypothesis. For the fertilizer, it is 0.79, which is greater than 0.05. So you're going to fail to reject the null hypothesis. And for the interaction, it's 0.6, which is greater than 0.05, so you're going to fail to reject the null hypothesis. So in this, what we're going to do is we're going to fail to reject the null hypothesis. And so I've got a little diagram here of the crop yields being spray and drip, and then ABC. So what I might do is I might do this. We'll come over here, insert, recommended charts. Box and whisker looks okay. That was a sunburst. That's what we did. But let's try the box and whisker. So we did the sunburst, but I just thought we'd try another one. So we've got the crock-hill. So we saw the sunburst, and now you can see the box and whisker. So the box and whisker tells you the crock-hills. So that concludes this video. The next video is going to be on repeated measure. So I hope you decide to watch it.